Hi guys, you're welcome to today's class. Today we'll be taking problems on energy. In our previous class, we took problems on work done. It's usually a 3 in 1 work done, work energy and power. I decided to take them one by one so that we can have enough examples to solve and students understanding it better. So today we're taking problems on energy and like we did on work done, it's still going to be a playlist so that, like I said, students can be able to understand how to solve them better. Okay, we have here on energy that a ball of mass 0.1 kilogram is thrown vertically upwards with a velocity of 20 meters per second. Say I, what is the potential energy at the maximum height? What is the potential energy PE of the ball when it reaches 3/4 of the maximum height moving upwards? Let's see how this goes. Like I usually say, most students when they see questions, they get scared. Seeing something like 3/4 of the maximum height tends to keep the heart of some students. But let's see how it goes. It's still going to be simple, like I've always made it. Solution. Okay, then let's see what we're given from the question. They're given. We have here the mass to be 0.1 kilogram. We have initial velocity u to be 20 meter per second. And we have acceleration due to gravity g to be 10 meter per second square. Now, first question states potential energy at the maximum height. PE at maximum height. And the formula for potential energy is equals to mass times acceleration due to gravity multiplied by height. But then we are given mass, we're given acceleration due to gravity, we're not given height. We have to get height. Now, getting height, let's say from the equation of motion, v square equals to u square minus 2gh. Sorry, minus 2gy, where the y is still height. Substituting values, that the v here, since it's not given, the v here, of course, it's not part of the question. V, since it's not given, assume it to be 0 square equals to initial velocity u is 20 square minus 2 and acceleration due to gravity, which is 10 multiplied by y. Now 20 square will be 400 minus 2 times 10 is 20 multiplied by y, we'll have 20y. Therefore, y here of 20y, therefore y here will be equals to 400 over 20 and y will be equals to 20 meter. That's 400 divided by 20. And this 20 meter is the height, still y. Therefore, from the equation, potential energy equals to mgh. That's mass times acceleration due to gravity multiplied by height. We substitute value. The mass here is 0.1 multiplied by acceleration due to gravity, which is 10 multiplied by the height, which is 20. Therefore, potential energy equals to multiply 0.1 by 10 and by 20, you have potential energy to be 20 joules. That's I. That is the maximum height. The second one, I say the potential energy of the ball when it reaches 3/4 of the maximum height moving upwards. Now this is 3/4, 3/4 of the maximum height, which is 3/4 maximum height. This should be equals to 20 multiplied by 3/4. It should be 20 by 3 will be 60/4, which is equals to 15 meter. Therefore, the height here is equals to 15 meter. Then, on the formula, potential energy, which is what we are asked to look for, the maximum height is equals to mgh. Therefore, E is potential energy equals to, substituting the mass, value of the mass 0.1 multiplied by relation due to gravity 10 multiplied by the height 15 meter. PE equals to, if you multiply 0.1 by 10 and by 15, you will have the answer to be 15 joules. That potential energy will be equals to 15 joules. As simple as that. Thanks for watching, and remain on the same playlist for another solution on potential energy. See you then. Bye. Hi guys, and welcome to class still on energy. Today we have here that a bullet of mass 60 grams is moving with a speed of 216 km/h. Question is, calculate the kinetic energy. Let's see how this goes. As usual, I'll divide the board. Now let's see what we are given. So given, we have here the mass to be 40 grams and the velocity to be 216 km/h. Solution. Now, to resolving this, if you really don't understand how it goes, you might make mistake. Now, we have that 1 kilometer is equals to 1000 meter. We also have that 1 hour is equals to 3600 seconds. We are to reduce this 216 km/h to meter per second. And I have taught this in mathematics among the last problems we took on mathematics. So if you have not watched it, go to watch them, because I really at least about 4 to 5 examples on conversion, so that when solving problems you really know what to do and how to go about it. Now we have here that velocity equals to, trying to convert 216 km/h to meter per second. We now have 216 km/h multiplied by 1 hour over 3600 seconds multiplied by 1000 meter equals to 1 kilometer. If you have gotten it this way, well arranged like this, you have gotten 90% of the whole problem. Now discover that hour will cancel hour, kilometer will cancel kilometer. If you multiply 260, if you 216 divide by, multiply by 1000 and divide, okay, 216 multiplied by 1000 divide by 3600. You discover that you have velocity to be That velocity here to be 60 meter, which is this per second. Now you have gotten velocity. But then we also have that 1 kg is equals to 1000 gram. Remember, the answer is in the question is in 40 gram. I have to be broken down in a way that it will be in kilogram. Now we have here that 40 gram over 1000. This will become, if you divide 40 over 1000, you will have that you will have 0.04 kilogram, which is the mass. Now the question says calculate the kinetic energy of the bullet. Therefore, kinetic energy here by this formula half mv square. If we substitute the values, we will have ke to be equal to 1 over 2, which is half, multiplied by the mass, which is 0.04, multiplied by the velocity, which is 60 square. Therefore, kinetic energy here will be equal to, if you multiply 1 over 2 by 0.04 and by 60 square, or let's just break it down. You have 1 over 2 times 0.04 divided by 60 square is 60 times 60, which is equal to 3600. Therefore, kinetic energy equals to multiply 1 over 2 by 0.04 and by 3600. You are going to have 72 joules. Therefore, the kinetic energy here is 72 joules. As simple as this. Thanks for watching, and remain yet on the playlist for more problem solutions on energy. See you next class. Bye. You're welcome to class, still on energy and still on the same playlist. We have here that a stone of mass 0.5 kilogram is thrown vertically upwards with a velocity of 10 meters per second. This question is find the potential energy at the greatest height, age, and the value of the kinetic energy on reaching the ground again. This is very practical. You throw a stone up, and the time it takes, the energy that with which it gets to the greatest height, and the value of the energy when it gets to the ground again. Just like it happens in reality. Now let's see how we can solve this solution. Like I always say and do, state the parameters that are given. The mass here is 0.5 kilogram. The acceleration due to gravity g is 10 meter per second square, and initial velocity here u is 10 meter per second. Now we have to find the potential energy at the greatest height. So we have I PE at the greatest height. Potential energy is created by mass times acceleration due to gravity and by height. But then, as we have solved something like this before, we don't have height. Okay, but we can get height from v square equals to u square. Sorry, this is from up down minus from up down up rather minus 2 gy. Substituting v here is 0 because it's not given, square equals to u here 10 square minus 2 times 10 times y, which is the height. 10 square here is 100 minus 2 times 10 is 20, and 20 divided by y becomes 20y. Therefore, y is equal to 100 over 20, and y equals to 100 over 20 equals to 5. Therefore, the height is 5 meter. Then we have that since potential energy equals to mgh, mass acceleration due to gravity, multiplied by height, you have PE, which is potential energy, to be substituting the mass as 0.5, acceleration due to gravity 10, and by defined height, which is 5. Therefore, PE, potential energy, equals to, if you multiply 0.5 by 10 and by 5, you will have 25 joules. Now, we also have that, and the value of the kinetic energy on reaching the ground. I also have that the kinetic energy equals to, on reaching the ground, you have mv square. Now, substituting the values, 1 over 2 and the mass, which is 0.5, times the velocity, which is 10 square. It's now 1 over 2 times 0.5 times 100. 10 square is 100. Therefore, if we count 1 over 2 times 0.5 times 100, that is half of 100, is 50. Therefore, 1 over 2 times 50, which is half of 50, kinetic energy equals to 25 joules. As simple as that. Now you see that both the potential energy and the kinetic energy are both 25 joules. As simple as that. Thanks for watching, and still remain on the playlist for other problem solutions on energy. See you next class. Bye. You're welcome to class, still on energy and still on the same playlist. Like I said before, we have here another question still on energy. I said it states a ball of mass 100 gram falls from a height of 5 meter onto a factor and rebounds to a height of 3 meter. Question is, what energy is lost by the ball as a result of the impact on the floor? Let's see how this goes. As usual, solution. Let's see what we are given. As usual, we have here the mass to be 100 gram, and there are two heights here. H1 equals to 5 meter, H2 equals to 3 meter. Sometimes these are the kind of questions that confuses students, but it's simple. And the acceleration due to gravity G is usually 10 meter per second square. Now, we have that. We have that 1 kilogram equals to 1000 gram. Remember, the mass is given in gram, and we have to convert it to kilogram. Therefore, 100 gram here will be equals to 1 over 1000 multiplied by 100. This is just the same thing as 100 divided by 1000. The mass here, therefore, the mass here will be 0.1 kilogram. Now we have the heights here. H1 as stated, we have 5 meter, and the H2 is equals to 3 meter. Now let's solve for H1, the potential energy at the first height of 5 meter. We have P E1 equals to mg H1 as the first height. We have here the mass here to be 0.1 multiplied by the acceleration due to gravity, which is 10, multiplied by the first height, which is 5. We then have potential energy, first potential energy, from the first height. If we multiply 0.1 by 10 and by 5, we have PE1 to be 5 joules. Now, we also have PE2 because of the second height. We have that PE2, which is equals to mg H2, and this substituting, we have the mass here to still be 0.1 multiplied by relation due to gravity 10, and the height here to be 3. Pa2, we multiply 0.1 by 10 and by 3, we will have 3 joules. Therefore, the energy lost on the reaction or the process of the ball falling will be equals to potential energy 1 minus potential energy 2, which is equals to 5 minus 3. Therefore, energy lost will be equals to 5 minus 3 to be 2 joules. As simple as this. Thanks for watching, and look out for more problem solutions. As a matter of fact, I think we have solved problems in work done, energy, and we'll be looking out for problem solutions in power. See you next class, and thanks for watching. Bye.